Hi everyone, my name is Isha and today I will be explaining a question of probability theory using Excel. So here is the question. The question states that the number of claims per year follows a negative binomial distribution with R equals to 4 and beta equals to 2. So claim sizes have the following distribution. So N here stands for claim sizes and Pn stands for probability of the claim sizes, which we are given for 1, 3, 5, 7 and 9. And S is the aggregate loss random variable. So we are supposed to compute probability of S greater or equals to 11. So we will look at this question in Excel. So the first thing, the question states that the number of claims follows negative binomial distribution. So here, let x be the number of claims. So x follows negative binomial distribution with value of r equals to 4 and beta equals to 2. So here we can compute the value for probability by using the negative binomial distribution, which is 1 over 1 plus b. And we can use Excel functions to compute for p. So the answer is 1 over 3 for the probability. And N here stands for the claim sizes, which is given in the question. So the first thing that we should do is calculate the probability of x, which can be done by using negative binomial distribution. So this is the PDF of negative binomial distribution with parameters r and b, where x can be 0 to infinity and r and b are given in the question. So in order to find the probability of s greater than or equals to 11, we must find 1 minus probability of s less than 11. So we can find the probability of s less than 11 by adding probability from s equals to 0 until s equals to 10. So before computing the values for probability of s, we must find probabilities of x. So we can do this by using negative binomial distribution feature of Excel. For example, when x is equals to 0, the probability of x is 0.01234567 This can be computed by using the negative binomial distribution feature of Excel. So in this first value we substitute should be the value of failures. So the number of failures here is x, which is 0, so we can just put G6. And for the second value we are supposed to put the value of success, which here is D7, which is value of R. And next we are supposed to substitute the probability of success, which is 1 over 3, and since it is not cumulative we will write here false. Moving on, so we will compute value for probability of s one by one for 0, 1, 2, 3 until 10. So we can start by computing for probability of s equals to 0. So probability of s equals to 0 is basically the probability of x equals to 0 because there is no claim. Moving on to probability of s equals to 1. So probability of s equals to 1 basically means probability of one claim with claim size 1. So this means x here is equals to 1 and n can take the values of 1, 3, 5, 7, 9. So s, the value of s can be just 1, 3, 5, 7, 9. And probability of x equals to 1 is 0.32921811, which we just computed here. And probability of n equals to 1. So this is basically probability of the values of n here. So probability of 1 is 0.3, probability of 3 is 0.2, probability of 5 is 0.1, and for 7 is 0.2 and 0.2 respectively for 9. So after computing the probability of n equals to 1, we can find probability of s equals to s by multiplying probability of x equals to x times probability of n equals to 1. So we get these following answers for all of the combinations here. Then probability of s equals to 1 is summation of all of these values here. So we get the final answer as 0.032921811. Moving on to probability of s equals to 2. So probability of s equals to 2 basically means probability of two claims with claim size 1. So this can be found by finding n1, n2. So n1 can take the following values and n2 will take the following values. And then s is just summation of n1 plus n2, which we can do by using Excel. And we can just drag the mouse down to find the values for all of the aggregate losses. But we need to make sure that the s is less than 11. So we cannot exceed the value of 10 here. So probability of x equals to x here is probability of x equals to 2. And the next column states probability of n equals to 1, which is basically probabilities of the values here. So when n1 is equals to 1, probability is 0.3, which is in this table. We can follow this tables to write the probability of n. So after filling up with all the probabilities here, then we can find probability of s equals to s by multiplying probability of x equals to x times probability of n equals to 1 times probability of n equals to 2. So after we found the probability of s equals to s, we just need to do summation of all of these values to find probability of s equals to 2. So we will get 0.0731138 as our answer. So we will apply this concept in all of the values for s. For example, here probability of s equals to 3 means probability of 3 claim with size 1 plus probability of 1 claim with size 3. So we have the values of n1, n2 and n3 respectively, and then we just need to apply the similar concept that we apply in probability of s equals to 2 and s equals to 1. But the number of n will keep on increasing because as we go from 3 there will be 3n. When we go to the number 4 we will get 4n. So number of n keep increasing depending on the probability that we are calculating. So the same way we find the probability for s equals to 3, that gives us value of probability of s equals to 3 as 0.017704618. Similarly, we do it for probability of s equals to 4. So here n would be n1, n2, n3 and n4. Again, we need to make sure the value of s should not exceed 10. Because we are finding less than 11, so it should not be equals to 11 or greater than 11. So you can see here all the values are within 10 or equals to 10. So here the probability of x equals to 4 is the one we calculated previously, which is 0.085352843. So after computing this the same way we compute probability of s equals to s, we can here use the Excel feature of product because there are many numbers to multiply. So we can do product from I83 to M83, which basically is probability of x equals to x multiplied with probability of n equals to 1 multiplied with probability of n equals to 2 multiplied by probability of n equals to 3 and n equals to 4. After finding all of these values for probability of s equals to s, we will do summation and find that we get probability of s equals to 4 as 0.009685346. So same way we will find the probability of s equals to 5 from n1, n2, n3, n4 and n5. And we will make sure that s is not greater than 11 or equals to 11. So we will compute the probability of s equals to s for all of these rows here. And then we can find probability of s equals to 5 will be 0.00231067, which is summation of P124 to P144. Here the value of x is 6 and n can be 1, 2, 3, 4, 5 and 6. So probability of x equals to x here is probability of x equals to 6. Following the next step by substituting the values for probabilities respectively, then computing probability of s equals to s by using the product from probability of x equals to x until probability of n equals to 6, all of these columns. So we will next see for probability of s equals to 7. The value of x here will be 7 and n can be n1, n2, n3, n4 until n7. Similarly, we just compute the values for the numbers we substitute here by using the same concept we did earlier. So moving on, for probability of s equals to 8, we will have n1, n2, n3, n4, n5 until n8. So we will make sure that s is not greater than 11 or equals to 11. And probability of x equals to x here stands for probability of x equals to 8. So we will write the probabilities for all of these values. Similarly, we will compute for probability of s equals to s individually for everyone. And then we will do the summation of those values. Probability of s equals to 9 is when x is 9, and this can be n1, n2, n3 until n9, but we cannot use any other values except of 1 here because it will exceed the number 11. So in order for us to get value of s less than 11, we can only use 1, and probability of x equals to x here stands for probability of x equals to 9. Similarly, we substitute probability of n equals to 1 in the cell here. So in this case, probability of s equals to s is directly this because it's just one value, which is product from n214 to w214, which is all of these values here from probability of x equals to x until probability of n equals to 9. Similarly, for probability of s equals to 10, only 1 can be used because it will exceed the value of 11 if we use any other number, for example 3, 5, 7 or 9. So we can only use 1. Similarly, we will get probability of s equals to s as this number here. So that will be our probability of s equals to 10. These are all the values which we just computed. So we can use Excel features to compute all of these values. So this is addition of all of these values from here to here to here, and all of the values highlighted in blue. After doing the summation of all of these values, we get probability of s less than 11 as 0.1132969. So probability of s greater and equals to 11 will be 1 minus 0.1132969. So we will get this as 0.886703. So this is the value that question has asked us to compute.